Today we're gonna talk about the physical design for the database system. So first we're gonna talk about the previous class, what we teach and what we learn. Previous class we discussed the logical and physical design, the differences between those two database models. And we introduced the ER logical modeling. And we learn about different elements about DFD. We learn about the differences for each level of the DFDs. And we also introduce the concepts such as content diagram, level 0 DFD, and level 1 DFDs. So we also understand the REA modeling related to the resources, event, and agent. So we understand that event-oriented focus, and we develop EER diagram based on the narrative description of the business, and we can also develop the REA model and DFD models by ourselves. So today's class, we will learn some new concept. First, we will learn how to convert ERA diagram into relational tables, which is what we learned previously from the chapter 2 and 6, right? We using access and we are based on the relational tables, right? So then we explain the conversion rules, which is very important part of this lecture as well. And then we're gonna explain the concept of the database normalizations, and then we're gonna describe the first, second, or third normal form. And this one will be the additional high requirement for this class. And then we will explain the relational database, like in the access and using SQL, and we're gonna explain how to form a relational database, right? So how this used to implementation information process. So this is a very high volume kind of class that we're gonna have for this semester. So previously, we're talking about the database and AIS, right? We have the reason why AIS existed is because the business event, business transactions, using the IT and accounting to process the information to support the decision making, this being replaced by many times by me in this class, right? So this whole process with all the information or the examples like doing the business transaction, this is serving for the accounting and the financial statement, right? On the other hand, using the database, we are using the SQL queries to get the accounting information, right? We design the database that carefully serve the potential users' need. Data modeling, which means data modeling is a process of defining a database to faithfully represent all aspects of the organization, right? We're using that as a way to make sure that the database is serving all users' need, right? So chapter 8, we introduce the ERA modeling, stuff like that, and we talking about the REA diagram. So all this information is all this kind of logical design of the database system is serving for the physical design of the database system, right? So how to implement, so chapter 9, we're gonna talk about how to implement an REA diagram in a relational database. So we want to know that we have a database, we want to insert, delete, update, right? Anomalies. So for instance, we want to store the employees' information regarding to their identification, right? Their department, their salaries, or what courses are they take and what are the grade they received, right? So by looking at this table is definitely not what we required for the database, right? First, absent of like primary key, and there is dual data entry, stuff like that. So, first question, what if we want to add another course for Margaret, right? So, potential problem gonna be insert anomaly. So adding new rules force the user to create a duplicate data. Another question, what if we want to delete a course? This causes a potential problem that delete anomaly. Delete rows might cause loss of data. Might be need for the future role. So what if we want to reassign Susan to accounting class, right? So update anomaly, which means like changing a role forces the changing of other roles because of the duplications. So these are all the problem. And we wonder why. It's because of the redundancy of the data. So what can be the solution for it? So the solution for the redundancy of the data can be relational database. So first we're gonna introduce the concept of database normalization, right? So redundancy is removed by breaking this one table into the 3 separate relations. First is employee table, second one is grade table, the third one is course table. So what is missing from this 3 table when we break down? Anyone?
What table, Professor?
I said when we separate this big table into 3 small tables, right? We remove the redundancy. So what is missing from these 3 tables?
The key, a primary key?
Yes. So primary key, we have no redundancy, right? So the goal of the database normalization is to minimize or eliminate the data anomalies. So how to link them? What's the problem with the current data? Is because they are missing the primary key. So we create a primary key, right? For each table, we create the employee ID, we create the employee ID and cross ID for the grade table, and we have the grade ID for the course ID for the course table, right? So then we can link them all together. We use the foreign key to link the table together. So then the question is how to achieve the database normalization. So this is back to the first question, right? We need to find the rules and determine whether the table conforms to the first, second, or third normal forms. So first we're going to talk about some important concept before we actually goes to the database normalization process. First concept we're going to talk about is functional dependency, right? So there are three types of functional dependency: full functional dependency, partial functional dependency, and transitive functional dependency. So first, full functional dependency, right? So if this attribute, it depends on all the key attributes, which means for instance, the primary key, all the key attribute, right? So this is a full functional dependency. So what is a partial dependency? So if a non-key attribute depends on part, but not all of the key attribute. For instance, the information about first name, last name, department, office is only depend on the employee ID. There is no relationship with the course ID whatsoever, right? So this case means that they have partial functional dependency. So what is transitive functional dependency? It is a non-key attribute, right? Depend on the other non-key attribute. For instance, if you belongs to manufacturing department, right? You have the assumption is each department has their own office, right? If you belong to this department, you definitely go to the same office. If you guys belong to the same department, you go to the same office, right? So this is called transitive functional dependency. Next, I'm gonna talk about the different normal forms, right? Normalization form. So you don't need to remember everything on this first table. You just need to remember the first three, right? First normal form is a table format, no repeating groups, and primary key identified, right? So second normal form is first normal form and no partial dependencies, right? Third normal form is second normal form and no transitive dependency. Next is also an example to tell you how to identify this scenario. The first is like in this table, in this relational database, the first one is we find the primary key. Primary key is in the blue color, in the green color, and with the a line underneath it, right? Have an underline. So the project number and employee numbers are the constant are both the primary key, right? And then the project number is going to decide the project name, right? So it's partial dependency, right? So for the job class and the charging hours, this is a transitive dependency, right? And for the employee numbers, right? So employee numbers decided the employee name, job class, and charging hours, which is also a partial dependency, right? So as we can see, identify from this example is helping us to understand what are the important components that we should do before we actually do the first normal form. So first, we're gonna talk about the first normal form. So it's a database table, right? And is a property of a relation in a relational database. A relation is in first normal form if and only if the domain of each attribute contains only individual values, and the value of each attribute contains only a single value from that domain, right? So, which means there is no repeating groups. The rules are each table cell should contain a single value and each record needs to be unique. So, what is the procedures? First, create a separate table for each set of related data. So for the previous example, we're using this, right? So we first separate into employee table and cost table. And then we identify each set of related data with primary key. So after that, we got the first formal form, right? So also called as first NF. After that, we do the second normal form, so also called 2NF, right? So this is a database table that qualified for the first normal form and include no partial dependency, right? So where the attribute is dependent on only one part of the primary key. So it has to meet the requirement of the first normal form, and an attribute is dependent on only a part of the primary key. So what is the procedures? What are the steps, right? So create a separate table for each set of values that apply to multiple records. So the second level, we have to further divided the grade table into two parts. One is the grade table and one is the course table, right? And we related this table with the foreign key. So this is the second normal form. So the third normal form is a database table that is said to be 3NF if it's in second NF and contain no transitive dependency. What that means is where a non-key attribute is dependent on another non-key attribute, right? So what are the requirements? First, it has to be eligible, meet all the requirements of the second normal form, right? And then we're gonna eliminate the attribute that do not depend on the key. So what are the procedures for that? Like these three tables are all the second normal forms tables, right? So we separate the table from transitive dependent attribute. So like employees, we only have like employee ID, first name, last name. We have the department ID for the department table, right? We can relate this table with a foreign key. And then the third normal form is completed. So the finally after this three steps, we get the final database normalization. We have 4 tables, 1 employee table, 1 department table, 1 employee grade table, and then 1 course table, right? And we all able to link them with the foreign keys from other table. So these 3 steps produce a normalized database, which means the data are consistent, redundancy is minimized or controlled, anomalies are avoided, and the storage space is efficiently used. So this is the benefit of constructing normalized database, right? So this is very important for you to do your homework, assignment, and you have to keep in mind of the normalizations, like no violations of all those things I mentioned before, right? So database normalization is one of the 2 basic ways to design a well-structured database, right? So normalization starts with the assumption of everything is initially stored in one large table. There probably duplication of the records, stuff like that, and that's motivates us, right, to create a set of rules that follow to decompose all the components into a normalized tables, which become the well-structured database. And the objective is to produce a set of table, right? Because it can be easier for people to update, insert, and delete anomalies, right? So semantic data modeling is another way to design a well-structured database, right? So the database designer uses knowledge of business process to fulfill the information need, right? So they have to understand the business process, the information users need, right? And the resulting graphics is used to create a set of relational database that are in the well-structured form, which is what we learned at previous class, right? The diagrams. So, like what we learned last class is 2 popular data modeling, ER data modeling and REA data modeling. The next part of the lecture, the secondary main focus of this paper, this lecture is for us to understand how to implement an REA model in the relational database, how the conversion becomes, and how you do that in reality. So there are very important rules, and you should not memorizing it, but have a pretty much good understanding about how this conversion can become. So students, there are students ask me about mandatory relationship and optional relationship. So I will be illustrate that in more detail for when we converting the ER diagram to the table, right? First rule, for one-to-one relationship, right? Collapse the entities participating in the relationship into a single table. What that means, so place order and customer table can be combined to the customer table, right? So rule number 2, for relationship other than one-to-one relationship, create the separate table for each entity, right? So for instance, this one is sales and receive cash. So these two need to create two separate tables, one for sales, one for receive cash for separate entity. And this is the same, right? Or you can see this is one to one, zero to many, right? This is 0 to 1 and 0 to many. So this kind of, other than 1 to 1, right? We also create two separate tables for each entity. Same with many to many, right? Rule number 3, create fields for each table based on the attribute identified in the REA diagram. Right? We remember that REA diagram, we have one entities, and then we have like square, and then we have attribute spread it out, and we have the primary key, stuff like that, right? So those attributes are become the field of the table. Like for instance, in this case, sales table have how many fields? Anybody? Yes, go ahead.
4.
Okay. What are them?
Sales number times on sale amount of sale and then date of sales.
Yeah. So this become the fields of the table, right? So rule number 4, designated the primary key in each table based on the attribute identified in the REA diagram, right? So every table in the relational database must have a primary key, and the primary key is
It's sales number.
yes. Good. So single attribute key, right? The primary key is usually a single attribute, but there are also sometimes which is not, right? There are two primary keys, or maybe more. So rule number 5, for one-to-many relationship, right? This is very, the word is not very easy to understand. I will read it out loud to you guys, but like we can use the visualization. I have the slides after help you guys to understand what the meaning of this, right? So post the primary key of the table on the one side of cardinalities to the table on the many side of the cardinalities. And then posted key become a foreign key in the table of the many side of the cardinalities. So, like, for instance, like in this case, right? The one side of the cardinality is employee. The many side of the cardinality is sales, right? So the employee ID, the primary key, become the foreign key of the sales table. Okay? So for instance, like this table, sales and initially stored in the big table, right? We separate it to the sales and employee table. And then the one side cardinalities, the primary key, become the many side foreign key, right? That's how they build the relationship. So as you can see, the employee ID is matching the employee ID from the sales, right? And also, like the sales number also become the foreign key of the employee table, right? We can see the sales number is matching with the sales table. Sales number of the employees table is matching the sales number of the sales table. But there are some problems. There are repeat groups, right? Every columns in the row must be single value, right? So when we constructing, this is called what kind of violation?
Entity integrity.
Yes, entity integrity violation, right? So how about the other one, right? So it's a violent relationship as well. So those two are actually wrong. So which leads to the number 6 rules. For many-to-many relationship, right? You need to create a new table for the relationship and assign the primary keys of each participant entity to a new table, result in a composite key for the new table, right? Adding any attribute unique to the many-to-many relationship is a non-key attribute in the new table. For instance, this is a many-to-many relationship. And then we first separate into the two tables. One is inventory, one is sales, right? But this is because of the many-to-many table. We have to create the first, we have the rule, right? We come up with, on the one side, to the many, we using this, the primary key of the inventory as the foreign key of the inventory sales. But this is a composite key, right? Because we need another one. We need the sales number from the sales table. And together, the item number and the sales number become the composite key of the inventory sales table. So it also called concatenated. So also called concatenated key, which is consists of two attributes that represent the primary key of each linked entity, right? That's the many-to-many relationship there. So in this case, right, we successfully converting this big table to a relational database table. So what's the problem of that? Everything is matching, right? Then we have a repeat group. As we know that every column in a row must be single value, right? So what's the solution for that? So we add one column for the sales with the item number. Then everything matched. But we still have the repeat groups. It has to be in single value. It's still wrong. So we need to talk about the optional relationships, which is rule number 7. Right? So we need to consider all optional relationships as having many cardinalities, whether or not the relationship is actually a many relationship. So we treat all the optional relationship as a many relationship, even they are not. Right? So we ignore the fact that relationships are optional and apply the 6 conversion rules for mandatory relationship. For instance, all those things, all those scenarios listed there, right? Optional. We all choose them to be many relationship. So the objective is to minimize the number of new values in the foreign key field in the database, which is undesirable because they make the result query unpredictable and they are not clear if the new value is actually the missing value or that doesn't apply to the data, right? So it's important to be distinguished between those two. So for instance, this one, right, we treat it as many. So this side is many, right? So what we're gonna do is we have a sales table with the sales number, and we have employee table with employee ID. So what we're gonna do? First, we're gonna add the employee ID as a foreign key to the sales table. And then we can find out that each sales number have a matching employee ID, right? And then we have employee ID table, which also have a sales number as a foreign key. But we result something about the empty column, right? In the sales number. We don't know whether this is a new value or whether this new value means missing or doesn't apply, right? Some employee doesn't engage sales. That's probably an explanation. Or this employee engaged with the sales but doesn't put their employee ID there, right? So that can be a problem. So how to resolve this problem? We treat this. Another example is inventory and sales, right? And again, we treat it as many-to-many relationship. For the inventory table, we are using build up a new table, right? First is the inventory table and the sales table. And then we have inventory sales table. We're getting the item number, sales number as a composite key for the inventory sales table. So these 3 tables with the data put in there, clearly we can see the relationship, how they link each table together with no duplications and with no entity or referential integrity violations, right? And then we have inventory sales if we just do inventory and sales without having the inventory sales table, then there will be not clear and new values, and we cannot interpret what's going on with it, right? So that's why we treat the optional relationship as a many. So in this case, right, if we don't build up it, we also receive the duplicate record repeating groups from the sales table. We not only have missing table, we are missing values from inventory table. We also have duplication values from the sales table. So both of these situations are not correct, right? So let's have an example to illustrate how we apply those rules into reality. How can we convert it, the REA diagram, into the relational database, right? So first, we have the REA diagram. Inventory, cash, resources, sales, receive cash, events, and customer, employee, customer, this is agent, right? We have this separate. And we also have a very more detailed kind of diagram. It's more comprehensive, right? Examples. So first step is not this like, I don't ask you guys to draw this. The requirement is just limited to this level, okay? You don't need to go to the next very comprehensive REA diagram. So from this is gonna be on the following like group assignment as well as on the exam, right? I'm asking you guys to fill in the table. So first, one-to-one relationship. Do we have one-to-one relationship in this? Actually, no, right? Then rule number 7, consider all optional relationship as having a many cardinality, whether or not in the relationship is actually a many relationship. Okay? So keep that in mind. So in here, you're gonna make some changes, right? This is, even though it's not a many relationship, you still need to do that. So rule number 2, for relationships other than one-to-one relationship, create a separate table for each entity. So any volunteer for what kind of table are there?
Is inventory table and cash table?
Excuse me, I didn't catch anything. Who is talking?
Inventory and cash table.
Yeah, inventory and cash. And then what?
And the primary key for inventory is
Oh, you don't
item
need to answer
number.
the primary key. Just tell me what are the tables there.
Customer table. I say customer table, employee table.
A sales table and a receive cash table.
Yes.
And sales table.
Okay. So first we identify one by one procedures. Okay. First is inventory table, and then is sales table, the cash table and receive cash table, customer table, employee table, and
Cash receipt.
and what?
Cash receipt.
Cash received is already listed there.
Oh, okay.
I guess it's inventory sales.
Rule number 3. Now we come to the rule number 3. First, we don't think too complicated. We identify all the elements that are listed in that. That's the first rung of the table, right? Try to identify. Then we go to more detail. We create the fields for each table based on the attribute that identified in the REA diagram, right? So inventory table. And then we decide the primary key for each table, right? So for inventory, we have item number, and we have descriptions, list price, right? As the other attribute, okay? The sales table have sales number, date of sales, time of sales, amount of sales, right? The cash have account number, bank name, type of account. So the cash receipt number, date of receipt, time of the receipt, and amount of the receipt. Right? Customer table have customer ID as a primary key, customer name, address, phone, stuff as foreign key, right? And then employee table, employee ID, employee name, employee address, etc. as other attribute. Now, rule number 5. We are identified from one-to-many relationship. Remember the rules that I told you. Post the primary key of the table on the one side of the cardinality to the table on the many side of the cardinality, which means the customer ID will be the foreign key of the sales number. A foreign key of the sales table. We look at the other ones. We identify that the employee ID will also be a foreign key of the sales table. Right? So follow these procedures, we can identify all the foreign keys of the tables. Right? We try to create it. So, and then we come to rule number 6, many-to-many relationship. What are the rules? Create a new table. This time we create a new table for the relationship that assigned as a primary key for each participating entity to a new table, which is inventory sales table. Some students already answered that question, which is correct. And then we constructed the primary key as 2 parts, which is both from the inventory table and sales table. And the foreign key, so add any attribute that unique to the many-to-many relationship as non-key attribute in the new table, right? The quantity sold, actual price, right? Then we consider all the optional relationship as having many cardinality, whether or not there are actually many relationships. Ignore the fact that relationships are optional and apply the 6 conversion rules for the mandatory relationship.
Professor?
Then we add
Professor, I have a question. Can you repeat the inventory and sales table part? Why we have the table, the inventory and sales table?
The thing is, inventory and sales table are many-to-many relationship, right? So for many-to-many relationship, we create a new table.
Oh, okay. So if it's many-to-many, we create a new table. But if it's one-to-many or one-to-one, we keep one table. We keep the original tables. Okay.
Yes. Yeah.
Thank you.
Welcome. So for the optional, right? If you see any circle, it's called optional, right? For the optional, you treat it as many, right? Then this become one-to-many relationship. So what you gonna do with it? So you gonna do is add the sales number into the cash receipt table as the foreign key, right? So this is the final table that we got. Is there any there are tables that doesn't really have foreign keys, so it's okay. It's not necessary that every table have foreign keys, okay? But every table must have a primary key. So finally, what you should do is check if your table are in third normal form, right? In general, so application of this conversion can automatically result in the second normal form. And in most cases, it also can result in the third normal form. But you have to double check. There are exceptions. The database table is said to be first normal form if contain no repeating group. I'm repeating this. This is very important. Okay, guys? So, second normal form is in first normal form, but also include no partial dependency. So, third normal form is in the second normal form and contain no transitive. So now we're gonna have a class exercise. You guys try to write down the table's name, primary key, foreign key, and the other non-key attribute in a table. This is gonna be similar to the exam. I'm gonna ask you guys to identify those things. Okay? So I will give you guys 10 minutes to write it down. And I'm gonna ask 4 students to talk about what did you put on each column.
So for attributes, we have to come up with them ourselves. It's not provided, right?
Yeah, but you can have some common sense guess.
Okay.
And it doesn't really matter. But the important part is the primary key and the foreign key.
Okay.
And the table. Okay. That's definitely gonna be the same. Just tell me all the tables' name.
Tables are inventory, cash, sales, receive cash, and receive cash, order inventory, receive cash. And receive cash inventory. Receive cash and disburse cash and cash. Oh no.
Okay, well, I'm gonna talk about the detail later on. We have step-by-step explanation. That's almost correct. Everything almost correct. That's very good. Okay, how about Amelia? Can you talk about the primary key for each table?
So the primary key for inventory item number. For the table cash account number. Order inventory order number. For the table receive inventory, I put receipt number. For the table disburse cash, I put cash disburse number. Employee table, the primary key is employee ID. For the
Yeah.
table vendor, I put as a primary key vendor number. And for
Yes.
the table inventory, order inventory, I put item number and order number. For the table
Yeah.
inventory and receipt inventory, I put item number and receipt number.
Yes. Okay, that's very good.
Thank you.
So how about the foreign keys? I think only few of the table have the foreign key. How about the foreign keys for different tables?
You mean like for the customer? No, for the order inventory, order ID.
Order inventory, right? For the order inventory table, the foreign key is actually employee ID and vendor ID.
Okay.
So
She said
how about the receive inventory table?
Which ones were the primary key? The primary key on the first the student talking is the foreign key on that table. He was what? Inventory customer ID or employee ID? No, vendor ID, employee ID. I think the employee ID is the foreign key on the second table. No, the primary key was employee ID.
Yeah.
Now the foreign key.
No. I mean, like, I think you're a little bit confused. I'm talking about if there is a table have foreign keys, what are the table and what are the foreign key of it?
So I'll start from the beginning. For order inventory, I have employee number, vendor ID, and item number. For receive inventory, I have employee number, vendor ID, and item number. And then for disperse cash, I have employee number, vendor ID, and account number.
Yeah, okay. So it's almost correct. It's still some little mistakes.
Yes, the item number I think shouldn't be there.
For order inventory?
No, for order inventory, for example, so the foreign key in the order inventory table is employee number and vendor number, right?
Yes, it's that one.
And she put the item number. I don't know, is that correct?
Yeah, okay. Let's talk about that in the details, all right? I will go through every rule with you guys. So the more important thing is you go through the rule and you eliminated the possibility of making any mistake, okay? So, okay, let's go through that one by one, okay? Everybody do a really good job in this. So, first of all, I want you guys, I don't know if, I think I put the rules already in your slides, but please make sure that you have this highlighted. This is very important. All the rules. And we will go through this one by one. Right? First is using rule number 1. Identify the one-to-one relationship. And in this case, we don't have any one-to-one relationship. Right? So we just skip that. Rule number 2. For the relationship other than one-to-one, create a separate table for each entity. Right? Inventory table, order inventory table. So we put those two in. Right? And then we repeat this table, repeat this procedure, this rule, and we identify all the tables that from this rule principle. We have some additional tables that not included here yet, right? And then we use rule number 3. We create the fields for each table based on the REA diagram, right? This is not like in the exam. If I want you guys to put that in, I will provide more details about it, right? Or I will expect you guys to have better understanding about what should be included, like common sense as a content, right? What do you think this will be important? Yes? What's your question?
No, I was about to ask, like, for example, on the test, like, are you gonna provide it? Because how are you gonna imagine those fields that belong to the inventory? You understand what I mean?
Again, I will ask you guys, if I provide it, you guys can follow my information that I provide. But if I didn't provide it, I expect you guys to have a common sense judgment.
Okay. Okay.
Can you turn off your phone during the class? Thank you. So if not, I will expect your professional judgment. But if you have a slightly differences, I won't deduct your point. Okay? I'm very reasonable in that. So rule number 4, identify the primary key for the table, right? So in this case, we identified all the primary key and other attribute. So these are the two, like, the fourth rule, the number 4 rule. And after that, you will be able to fill most of part of the table, right? Because as I said, not every table have foreign keys. So next step, rule number 5. For the one-to-many relationship, right? We use that rules. We post the primary key of the table on the one side of the cardinalities on the table to the table on many side of the cardinalities. And we posted key become the foreign key in the table of the many side of the cardinalities. So we repeat these procedures. So employee ID is the foreign key of the order inventory, right? And then this one, vendor ID become the foreign key of the order inventory table. Employee ID become the foreign key of receive inventory table. Vendor ID become the foreign key of the receive inventory table. Vendor ID become foreign key of the dispersed cash table. Employee ID also become the foreign key of dispersed cash table. And then account number become dispersed cash table's foreign key, right? By doing this, we can put all the information. Rule number 6, many-to-many relationship. We will create a new table, combine those two entities, right? So we have one many-to-many relationship, two many-to-many relationship. So we're gonna create 2 new table based on that. One is inventory order inventory table. Another one is inventory receive inventory table. And we're gonna include the information. So those other attributes is not really the getting point, kind of key point of the table, but you have to put information there. But the most important part is in here, right? The first 3 columns of this table. Next, we're gonna deal with all the optional relationship, right? So this become a many-to-many relationship. Then we gonna create a new table. Inventory receive order inventory receive inventory table, right? The primary key is from those 2 tables. And then this one become a one-to-many relationship, which lead to having the receive report number receiving report number as the foreign key of the dispersed cache table, right? So after all the steps, the final table become like this.
Professor?
Yes.
Why is receiving report number a foreign key as well?
So in this step, as I said, all the optional treat as many, right? Initially, this is a one-to-one relationship, right? So because it's optional, it becomes a one-to-many relationship. So for the one-to-many relationship, we have the rule number 6.
Oh, okay. So if it's one-to-one optional, then we read it as one-to-many optional.
Yes.
Okay.
All the optional, all the rule number 7, all the optional is treated as many cardinality, whether or not the relationship is actually a many relationship. Right? Why we do that? Because we don't want the empty. We don't want the newer entry or in the database because we don't know whether the value is missing or not, right? This is the principle that we teach previously. So because of this, after we do all the many to many, we deal with this one to many and one to one as one to many, and then we add the receiving report number as the foreign key. So this actually is very important part of the test, right? So whether you include this receiving report number is very, very important. Okay, so this is the final table, right? As I said before, this 3 column is important, and the last one is due to your understanding of the business process. So let's have a break for 10 minutes. So let's come back at 7:35, and we're gonna talk about the next part of the class, okay? Some other, like, a lot of slides that I need to cover today, okay? So again, these rules are very important. And these rules are going to be the guidance rule that you use when you create converting the REA diagram to the relational database, right? And the last part, if I didn't remember it wrong, you guys need to create an access file for this based on the relational database, right? So this is the procedure that we're gonna use. So these are the example that I mentioned in the previous class. So the main principle is you have to follow the rules step by step, and then you're gonna get the finalized result. Okay, so if you do not follow that, and you potentially gonna lead to some mistakes, right? So after we do all the conversion, we need to check whether this table is a normalized insert normal form table. This is very important. And once again, I'm gonna talk about this, the concept of first normal form, second normal form, and third normal form. This will definitely be on the final exam as well. Okay? So the functional dependency, like 3 types of functional dependency, you guys have to have a very clear idea about, because this is going to be important for the second normal form and third normal form, right? Second normal form is eliminate all the partial functional dependency, and the third normal form is eliminate all the transitive functional dependency, right? The example I already talk to you guys during the class before the break. Implementing an ERA diagram in a relational database. Like, what are the important principles? Important steps, right? So first, you want to create the table, right? But create table, this is not the finalized table. When you apply different rules into this, you will find there might be a need for additional table, right? So you designate the primary key for each table. This is a very important part. You can name it differently, but as long as the meaning is the same, you can call it employee number or employee ID. Both work as primary key for the employee table. That doesn't matter, right? So then, after you designated the primary keys, right, you want to establish the relationship between the table. As I said, every table must have a primary key, but not every table have foreign keys, right? But for those tables who have the foreign key, they actually have a relationship with other tables. And in addition, the next step, you want to create the forms for the event that are recording the processes. And then you create the forms for maintenance process. And then you create the queries that can report to the all reporting process, right? You want to be able to get useful information. So this is back to the stage that we want to get useful information of the database, right? We create form, we using the database that we create access form, right? We want to get information out of it. So how can we get the information that we want? So let's do a brief recap about this, right? So first, after we have the REA diagram, right? We construct the table, the relational database, right? So we find the tables and all the potential tables and how those tables are related to each other using the foreign key. So this is just one of the steps, right? To get the useful information, we need to use technologies, right? So such as using coding, using SQL queries to get the information that we need, right? So this is back to what we learn before the exam, midterm exam, right? After we go through all the process by ourselves. So the example is create a report that show employee name, sales date, and total amount of sales made for an inventory item, iPad Pro, by each employee in January 2018, where the total amount of the sales is greater than 1,000, right? So in the exam, I'm gonna give you guys some requirement like this, and you're gonna write the SQL query of this based on the previous understanding about the database, right? So the output table will be like this. Have an employee name, have a sales date, and total amount of sales, right? So etc. This is the output, ideal output table. And then this is the relational, this is the REA diagram and the relational database information. Right? Now we need to think about the way that we could get the information of this requirement. So I will give you guys 5 minutes. Try to write some code. And I will ask each of you to put the code in the chat box. Okay? Doesn't matter if you are right or wrong. We're gonna go through this one by one. Okay? So let's try to do that in 5 minutes. If you guys didn't finish, I try to give you guys some extra time. Okay? So right now is 7:51. So I will give you guys a hint of the time till like 7:56. And everyone try to reply in the chat. Okay? I want to see like how much code that you guys can come up with in this like 5 minutes. Okay? So I think you guys have like enough time. So I mean, for the exam, I hope you guys can write it faster. Okay? I saw a lot of you are in the right track. I'm very glad to see that. But I hope you guys can do that faster. So first, we want to select the items, right? So the employee name is from the employee table, right?
Mm-hmm.
The sales day total amount of sales are from the sales table. So first we identified the stuff from which table, right?
Yes.
So first thing we're gonna start with select.
Mm-hmm.
Select employee.employee name, sales.date of sales, and then sum of sales, amount of sales. First, this is the output we're looking for. So we select the output first. Right? The logic is like that, okay? Everybody needs to go through with me with the logic. Right? Next step, we are looking for the inventory item that is iPad Pro, right? Which is from the inventory table. We have the description. And also, there is a connection between the sales and employee, right? The employee ID is the foreign key of the sales table, right? So from employee, we inner join sales on employee ID, employee.employee ID equals to sales employee ID. Is that enough? No, right? We have to inner join other things too. If you're not talking, please mute your mic. Thank you. So next, we find out there is a relationship between the sales and inventory, right? We have a sales inventory table. So we got the sales number, right? So inner join sales inventory on sales number equals to sales inventory dot sales number. We do inner join second time because there is a connection between inventory and sales, right? And then the sales inventory also using the item number. So we do inner join inventory on sales inventory item number equals to inventory dot item number. So you understand the logic is more easy, right? After that, we need to identify the description for the iPad Pro. will, so what we gonna do that? We're gonna use where command. Inventory dot description equals to iPad Pro. Right? Next, we're gonna select the transaction happened between the January 1st, 2018 to January 31st, 2018, right? Then we use and sales dot date of sales between this period of time. And the last requirement, where the total amount of sales is greater than 1,000, right? And we will also sort it by each employee. So what we gonna do? First we sort, okay? So group by employee, employee name, sales, date of sales, and then the number need to be over 1,000. So having SUM, sum of sales, amount of sales that over 1,000. So this is the whole procedures. And remember to, like, in the drawing has to be, have a tab in. So if during the exam you didn't put a tab in, you couldn't get the code to work. It also will deduct point. I mean, in the drawing, you need to use a tab. Like click the tab, T-A-B, on your keyboard, right? To make it inside. And remember the how many appendices that you're gonna use.
Oh, that means it has to be on the second line when you write the inner join. That's what you mean?
Yeah.
Okay, when you press, okay, I got you.
Right? And the parentheses that you're using, make sure you close it. Like after the from, you have two, because this side is using for this, and the outside one is using for this one. Make sure the apprentices that you're using. Right? So, for instance, later on, you can try to create a database if you want in Access, right? And name like that, and try to run the code. If it's not working, try to fix it a little bit. Play with yourself, right? So now I'm gonna provide you guys a summary, right? So in this chapter, we learn about how to, in the keyboard.
On the keyboard. So how to do that? Like I write something, I click on that to go to the next one.
I think like if you are typing something like in Word, right? It automatically give you empty space.
Yes.
Right? So that's how it works.
Thank you.
You should try it on the Word or anything like anything in the like with the text, and you can use that. You can see how it works. It just give you an empty space.
Okay.
Yeah.
Thank you.
So let me go back to the summary of this chapter, right? This chapter is the main purpose is we understand the physical design of the database system, right? We learn how to convert the ER diagram into the relational database. We talk about the conversion rules for one-to-one, one-to-many, many-to-many relationship. And we also based on those rules are based on the mandatory and optional relationship, right? Then we understand the concept of the database normalizations, like first, second, and third normal forms, right? So, and also we also touch base with the process of implementing tables in relational database system using Microsoft Access. right? And then we learn how to form a relational database management system that use to implement, right, information process as an example in the SQL, right? So in the next chapter, we will describe the differences between risk and exposure. We're gonna talk about the control. We're gonna talk about preventive, detective, and corrective control, right? Then we will also understand the main differences between general and application controls, right? So this is pretty much the chapter 9 that we're gonna cover.